So I started to create the models by comparing profit to all the categorical variables, and I found that the categorical variables that were the most correlated with profit were season, month, and genre. So then I looked at the relationships between profit and all the other variables, and I picked out the variables that correlated the most with profit, and that's how I started to make the model. And so here's a list of the highest correlating variables with profit. And so these are the ones that I used to begin making my model. But I decided not to use total box office because you would need to wait until the movie stopped playing to find the total box office, and by then you would know the profit, and not use profit budget ratio because you need to know profit before you calculate profit budget ratio, so there'd be no point, right? So the other variables I used to begin making the first model. So here we go. Here's the first model, and here I use the 5 variables, and I find that sequel number, so whether it's a sequel or not, isn't as significant as the other variables are. And you see that we have r squared. That's pretty high. It's 0.6. So I decided to take out sequel and then do my next model. And in this one, we have that the IMDb ratings, the least significant variable for explaining profit. And the r squared is still about the same, 0.6, 0.64, 0.63. Not much has changed. When we look at the QQ plots, we do see that the QQ plot has a pretty close line, but then it kind of trails off here. And it doesn't have really like a pattern here, but it's kind of clumped together. It's kind of really smushed together, and then there's like these outliers right there. Anyways, we find the p-value, and if I'm correct, because this is less than 0.5, our models have changed significantly, or our model hasn't changed because it's not less than 0.05. So then moving on to the next model. My next model, I take away the IMDb rating, and I was just messing around with the logs, and I found that this log, I just took the log of the opening box office, and you should probably fix this a little, or I'll go back and fix this a little bit. Took the log of the opening box office, and now I've removed IMDb rating. So this model only has 3 variables, and we see that our r squared has dropped significantly. So this is not a good model. And but we see here, like, really strange. Like, it looks like there's no pattern, but you can see that it's kind of like downward trending. And here you see that it kind of sticks closer to the line. There's a fewer outliers. And let's see what this, our next model. In the next model, I take off the least significant variable, and my last model only takes into account budget and opening box office. And we see that this model has 2 variables, but now has an r squared of 0.5, which is significantly higher than 0.2, even though we took away another variable. So that's basically what I found, was that we could use this model, this last model right here, that uses the least number of variables, but gives us a pretty high R value of 0.5, or we can use the first model that was way over here, let's see, that was right here, that uses all these variables, but only it gives us this r squared of 0.6. So it's more accurate, but you need to know all these variables. So that's basically what I found. I feel like maybe I could still fine tune it a little, I guess. But yeah, that was basically my conclusion. You can either have a model with 6 variables and get an R value of 0.6, or you can have a model with only 2 variables and get an R value of 0.5. And I feel like if you're talking business, it'd be easier to get to just use the last model that we got, because it's easy to find those 2 numbers, and it's much harder to find all 6 of the numbers that are required to use the first model. So then, let's see what I do here. Yep, that's our last model here. The QQ plot still doesn't have a pattern, but it is kind of cluttered. We still have these crazy movies. And I think in one of the explanations I go on to talk about how this movie is frozen here. I don't really know what movie that is, but it's like a tremendous outlier. So then I try making some predictions based on the model that we got, the 5th model, the one that only uses 2 variables. And so I tried to predict Noah, which is ranked 12, which I figure is close enough to like being one of these, not necessarily the top one, because obviously our model doesn't apply to really high grossing movies. It kind of applies to middle of the road movies. And so I picked number 12, and I plugged in what it made the first weekend and the budget, and I got this number, the estimated profit. And I was kind of confused because it means I didn't understand how to interpret it, so I could probably work on that. So yeah, that's how I did the models, and that's basically the conclusion that I came to. I'll just re-say it, that we can either use the first model that had 6 variables and had an R of 0.6, or we can use the last model, which only had 2 variables, but it had an R of 0.5. So it really just depends. Yeah, I feel like maybe we could also try to take out some of the outliers, take out maybe the top 10 movies and see how well they correlate, or how well like the model works for them, because I feel like some of the, probably like the 10 top movies are really like putting us like out here, like they're out here, right? And most of the movies fit like this model. Yeah, there's Frozen, and this number 2, it's Iron Man. This is point number 1, and that's like the Hunger Games. And you see that like maybe if we remove these values, our model would fit better. Anyways, that's it. Let me know if you have more questions.